So here we have Unit 5 and the presidential election. So we've got a simple random sample of 350 American voters. You find that 210 of them feel there's at least one presidential candidate who would make a good president. We're going to use our findings just from this to answer quite a few questions. So right here, this is our sample proportion. So 210 out of 350 gives us 0.6. Okay, so Gallup, a very renowned statistics company, just released a survey saying that the true proportion of people that feel there's at least one presidential candidate who would make a good president is 66%. And so that was actually pulled from the article attached to the back of this paper. So does this study indicate that the true proportion has decreased? Use a 5% significance level, all right? So alpha equals 5%. We saw from up above our p-hat is 0.6, and the believed population proportion is 0.66. So we know that I'm going to have you guys check all the conditions because I don't want this video to run too long and that gets a little bit tedious. So just pretend over here I checked all those pesky conditions. And so we know that this is going to follow a normal distribution. So I believe the true proportion is right here at 0.66. And then if I were to sample over and over and over again, my sample proportions would fill out this normal curve. Well, the p-hat I saw was 0.6, so let's say that's over here. How unusual was it to see this sample? Right? Because if it's really, really unlikely that that happened by chance, then we have good reason to believe that Gallup's number is no longer the same. So we'll run a hypothesis test. This is going to be a 1 proportion z test. Okay, so we'll run that in our calculator. I'm not going to do that by hand because I'm trying to keep these videos short. So let's pop up our calculator and we'll go ahead and clear all that. Okay, so we will conduct a 1 proportion z, oh, did I say interval or test? Okay, no, I said test. So 1 proportion z test, that's number 5 there on our calculator. All right, the believed proportion is 0.66, the null. And I want to know, well, how weird was it for me to see 210 out of 300, oops, let's just clear that, 210 out of a sample of 350. How weird was that? Was that unusually low? So has the true proportion gone down? Okay, and so we can either calculate or draw. I kind of like the draw option just to make sure that my picture kind of matched that. Yeah, so we can see that little shaded piece represents the p-value. So we end up with a p-value of 0.0089, which means an observation that unusual is going to be about 2.4 standard deviations to the left of the mean. So we see that that's pretty unlikely. So my null, I should have written that down first, sorry about that. My null hypothesis was that p equals 0.66. But I was wondering, is it possible that p has actually gone down, it's decreased? Okay, well, since we get a z-score of negative 2.36 and a p-value of 0.009, we'll call that, p value is less than alpha, right? 0.009 is less than 0.05. So the P is low, we will reject the HO. So we reject the null because, and you can just kind of record this little piece over here. So we reject the null because 0.009 less than 0.05. So we have sufficient evidence that the true proportion, so whatever our alternative was, the true proportion has decreased. And there we go. We've got our one proportion z test. We conducted a hypothesis test. Okay, explain what that p-value means in context. So in context, if the null is true, so if the true proportion of Americans who blah, 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 that's a really long context, the Americans that believe there's one good candidate is truly 0.66, then there's a 0.9% chance that we would see a sample proportion of 0.6 or more unusual. Okay, and so that just comes back to our picture. So if this is the true center, 0.66, then the chances of seeing a p-hat that unusual, there's a 0.9% chance. That's a very, very slim odds. Is it possible? Yes, but probable? No. So we reject. Okay, construct a 98% confidence interval for the true proportion of people who think there's at least one candidate who would make a good president. So that was why I kind of wrote blah, blah, blah right there, because I didn't want to write all of that. But that's our context. And so the 98% confidence interval, this I am not going to do the formal way. I'm mostly just going through this video to give you guys the answers, so you can check that. But I would have liked you guys to check your conditions, draw a picture, all that fun stuff. And you should have ended up doing a one proportion z interval. Okay, so a one proportion z interval, we'll find that with stat, and one proportion z interval is pretty low down the list. There we go. Okay, so I want to know 210 out of 350, what is that true proportion using this sample proportion? So I want a 98% confidence level. So we calculate and we get, so between 53.9 and 66.1. Oops, got a little sloppy there. Okay. So for here, the 98% confidence interval says that the true, so I'm 98% confident that the true proportion of people who think there's at least one good candidate is between 53% and 66%. Well, hold on. I had just said I don't think it's 66%. I wasn't thinking this was the true proportion. Why has that not agreed with my original conclusion? So that's question D. Does the conclusion from the confidence interval confirm or contradict your conclusion from the hypothesis test? Well, it contradicts it. Using the confidence interval, we would fail to reject the null because 66% is in the interval. So why? Well, we ran let me just draw the picture for this and talk. So up here, we ran it at 5%. Okay, so we ran the hypothesis test. With that shaded piece representing 5%. Okay, our p-hat fell into that 5%, so we rejected the null. Well, down here, if I'm looking at a 98% confidence interval, well, now I've only got 1% out here. So I've only got 1% now as my rejection region. And so if we're thinking about the picture, that means that sample that I saw is now not unusual enough with these new standards, with this new rejection region. It doesn't meet the unusual criteria. And so that's just kind of important to notice if you're trying to do this via confidence interval, making sure you're aware of what your significance level would be. So that's why that contradicted. What level of significance would match a 95% confidence level? Well, 95% confidence level for this, since this is one tail, we're again only looking over here, that would be a 2.5% significance level. So alpha equals 0.025 or 2.5%. What would the conclusion to the hypothesis test be if that level of significance was used? Well, it would be the same conclusion because 0.009 is less than 0.025. So we make the same conclusion. All right, explain type 1 error, type 2 error, and power. Explain what those mean in context. I think that's a typo on my part. The context here is very long, so let me go ahead and copy it. Okay. So we're looking at the true proportion of people who think there's at least one candidate that would make a good president. All right, this computer's moving a little slowly right now. Okay, so type 1. Type 1 is going to be, we say the true proportion of people who think there's at least one good candidate would make a good president has decreased, but it hasn't. Type 2, we don't say the true proportion of people who think there's at least one good candidate has decreased, but it has. Oh, hold on, did I mix those up? Oh yeah, nope, that's good, but it has. And power is the probability we say the true proportion has decreased, and it actually has, so we reject when we were supposed to. All right, suppose you conduct the same hypothesis test with a 10% significance level. How would the type 1, type 2, and power be affected? So if we're thinking about increasing our alpha, so I had an alpha of 5% from my original hypothesis test. I just said, hey, let's bump that up. Let's make that 10%. Okay, how would the type 1 error change? Well, type 1 error is alpha. So if alpha goes up, type 1 goes right with it. So type 1 goes up. So type 1 goes up, and we'll notice here, if we come back up to the confidence interval idea. So at 98% confidence, that means that 98% of all possible p-hats that we would fail to reject are in that region. And so if that region shrinks, type 2 shrinks. Okay. And so anytime type 2 shrinks, power goes up. Okay, these two right here, type 2 and power, they always will go opposite directions. Always, always, always. Okay. All right, so now our sample size has changed. So how does that affect things? 621, so that's more. So n has gone up. N going up is a good thing. N going up is good in general in statistics, just because it gives us more data and more information, again, in general, is useful. So if that helps you remember it, so as n goes up, your power goes up. And if we remember, power is 1 minus beta. So if this number is getting bigger and bigger and bigger, then that must mean that beta, our type 2 error, is getting smaller. Again, those always move in opposite directions. Okay, so power goes up, type 2 goes down. Well, what's happening to alpha? Well, alpha stayed same, so type 1 stays the same. Nothing more to it. All right, so you decide to conduct a study of millennials and Gen Xers. So we want to know, is there evidence that the proportion of Gen X is significantly higher than millennials? Okay, so I'm going to denote the proportion of Gen Xers as, oops, let me start over. I'm going to denote the proportion of millennials as P sub M, and I'm going to denote the proportion of Gen Xers as, anybody want to guess? Nobody? All right, P sub X. Okay. So we have sample proportions for each of these. P sub M is this 472 out of 800. Let me do that real quick. 472 divided by 800. So the sample proportion for millennials that think there's at least one good candidate is 0.59. And then this other one, this is going to be 378 out of 560. So 378 out of 560 gives us our sample proportion of Gen Xers. Okay, so let me type this so it'll go a little cleaner. So we saw a difference in our samples of negative 8.5%, right? So we calculate that, we're doing 59% minus 67.5%. Gives us a negative 8.5% difference. Okay. Now, what that means is if 60, so it means that Gen Xers were 8.5% more likely to believe this, to believe that there's at least one good candidate than millennials, right? So this percentage of people and this percentage of people had a difference of 8.5%. Okay, well, so what? We don't know if that's interesting, so we have to test it. So I have to say, I don't think there's a difference. I think these two groups of people, Gen Xers and millennials, are going to believe the same thing, right? Because that would be boring. That would be uninteresting. Well, maybe millennials are actually less likely to believe that than Gen Xers. So here's my null and my alternative. And so just a general tip, I'm going to just stick with millennials as group 1 and Gen Xers as group 2. And that's going to save me some headache time when I get down to my conclusion and when I'm writing these, so that the order, and same in the calculator, just it helps to have consistency across the problem. So we're going to conduct a 2 proportion z-test, and hopefully it's all coming together. See how this problem differs from part A. That was a 1 proportion z-test. So we'll do a 2 proportion z-test. That's number 6 right there. And so we have, let's see, we have 472 out of 800. And see here, this is group 1, so I'm just staying consistent. And then I have 378 out of 560. 378 out of 560. I think that P1, group 1, the millennials, is less than P2, group 2, the Gen Xers. Okay, I am going to just calculate. I don't feel like drawing. This video is running a little longer than I wanted it to. All right, so we see a z-score of negative 3.19 and a p-value of some very, very small number that I'll jot down on the screen over here. Okay, so I get a z-score of negative 3.19. And what that means is I thought the difference between these was going to be 0, right? I thought p sub m minus p sub x would be 0. Well, what I saw was negative 8.5. I saw that a lot bigger. Well, that's negative 3.19 standard deviations away. So the difference I saw, p hat minus p hat, was really, really weird. Well, how weird? That's where the p-value comes in. My p-value was 7.197 times 10 to the negative 4th power. So if we're just thinking that's 0.0007, that's that number. Okay, so we are going to make a conclusion here, and I'm going to type it. Okay, so we reject the null because p-value is lower than any reasonable significance level. 0.0007, just kind of recording that p-value again. This means we have sufficient evidence for the alternative. So we have sufficient evidence that the proportion of group 1 who feel like there's a good Prez candidate is lower, right? I said group 1 I thought was lower than group 2. So who feels like there's a good, okay, so proportion of millennials who feel like there's a good candidate is lower than the proportion of Gen Xers who feel that way. Okay. Let's wrap this up. Explain what the p-value means in context. So in context, if there really wasn't a difference, then there was a 0.07% chance, right, using that p-value, that I would see a sample difference between millennials and Gen Xers that was negative 8.5%, so sample difference, or more unusual. All right, 95% confidence interval. So 95% confidence interval, we're just going to use our calculator. This is a 2 proportion z interval. And I have this calculated off to the side. This is negative 13.6% and negative 3.3%. So just using this little sample, I am 95% confident that the true difference between millennials and Gen Xers who think there is a good president candidate is between negative 13.6% and negative 3.3%. And that would be your interpretation of that confidence interval. I'm going to expect you to finish your poster on Tuesday if this is your problem. So please come see me Tuesday if you have any questions, because test is Wednesday. All right, that's it.